A factory manufactures two kinds of ice skates, racing skates and figure skates. The racing skates require 6 work hours in the fabrication department, whereas the figure skates require 4 work hours there. The racing skates require 1 work hour in the finishing department, whereas the figure skates require 2 work hours there. The fabricating department has available at most 120 work hours per day, and the finishing department has no more than 40 work hours available. If the profit on each racing skate is $10 and the profit on each figure skate is $12, how many of each should be manufactured each day to maximize profit? What is the maximum profit? Assume that all skates made are sold, and we are letting x equal the number of pairs of racing skates and y equal the number of pairs of figure skates. So we have a lot of information here. So I'm going to set up our table, and x is the number of pairs of racing skates, y is the figure skates, and then we have the totals column. So what types of information do we have? We have fabricating, we have finishing, and then we have profit. So fabricating for racing skates, fabricating is 6 work hours, and for figure skates is 4 work hours. And the total is 120, so at most 120. So this is going to be less than or equal to 120. Then for finishing, that is 1 work hour for the racing and 2 work hours for the figure skates. And that is no more than 40. So that is less than or equal to 40. And then lastly, the profit, that is $10 for racing and $12 for the figure skates. So 10 and 12. And this is what we're trying to maximize. Next, I want to translate these into equations. So my objective function is going to be 10x plus 12y, because that's what I'm trying to maximize. And my constraints are 6x plus 4y is less than or equal to 120, and x plus 2y is less than or equal to 40, as well as x has to be greater than or equal to 0, and y has to be greater than or equal to 0, because this is real life. So those are my constraints and my objective function. So I can put my objective function over here. So I want to graph my constraints, but I need to isolate for y. So let's do that work right now. I want to subtract 6x from both sides. And then divide both sides by 4. And this reduces to negative 3/2 x plus 30. So this is one of my lines. And then the other one, x plus 2y is less than or equal to 40. If I subtract x from both sides, and then divide both sides by 2, this will be negative 1/2 x plus 20. So that's the second line that I want to graph. And then I also want to graph y is greater than or equal to 0. So I'm ready to go to the y equals menu on my calculator, and I want to type in my three equations, so negative 3/2 x plus 30, negative 1/2 x plus 20, and then 0. And I want to set my window, and I know that one of my lines crosses up here at 30. So a good window would be a little bit more than that. So I'm going to make my x max and my y max both 32. And then press graph, and this is what my graph looks like. So now I'm ready for the shading, and I like to do the reverse. So this was less than or equal to, but I'm going to do an upper shading. The second one was also less than or equal to, but I'm going to do the reverse. I'm going to do the upper shading. And then it was y is greater than or equal to 0, but I'm going to do the reverse. I'm going to do the lower shading. And this is what our graph looks like. So the feasible region is the region where there's no shading. So this region right here. And manually we need to cut off this region right here because, again, x has to be greater than or equal to 0. But we can't graph x on our calculator, so we need to know that we don't want to include this region here. So now I'm ready to get rid of my shading on the calculator so that I can find my intersection points. So I'm going to change all of these back to lines and then regraph it. And before I find my intersection points, I want to graph the picture on my paper. So it looks something like that. And my feasible region was right here. So now I just need to find my intersection points, or my corner points. So now I'm finding the intersection points on the calculator, and I'm skipping some of my steps here. So if you would like to see how to do all of the steps, like the first curve, second curve, and guess, you can refer back to some of the previous videos which talk about it in detail. But for the sake of this video, I'm just doing the final intersection points. So we have one at 10:15, one at 20:0, one at 0.20. So I want to label those on my graph. And we have 0, 0 here as well. So these are my corner points, which are my candidates for the maximum. So if we plug 0, 0 in, we get 0. If I plug 20, 0 in, I get 200. If we plug 0, 20 in, we get 240. And then if we plug 10, 15 in, we get 280. So that is going to be our answer, but we need to put it into context of the problem. So our final answer is going to be the max profit is $280 at 10 pairs of racing skates and 15 pairs of figure skates.